just a recap of what we said yesterday about a variety of seeds in agriculture. What are some of the varieties that we have? Seed bank, seed storage, and so forth. Today I brought real exhibits. To see the maize seeds that we normally have around. You can pass them around. They are not really they are interesting seeds. We have yellow, we have white, we have the blue varieties. So that is something that tells you that some of these seeds, especially the yellow ones here in Kenya, will disappear with time and will remain with the white. The traditional ones, like the red ones, are actually scarce. So we need to start thinking, right funding opportunities or proposals that can be able to propagate these seeds. Yeah, yesterday I told you about Sarach, which is about to disappear, but the Egerton University is developing a research community to be able to preserve those Sarach and other seeds so that they don't get lost over time. So today we look at introduction to climate smart crop production. Okay. As we said yesterday, everything is actually supposed to be smart. So crop production, smart crop production. Okay? And in this case, it's adapting agricultural climate changes for sustainable food security. Without food, it would be impossible, okay, to live, because there are things that we cannot do without. One is the food industry, and the other one is the health industry. We cannot do without those two. So we have to have a climate health systems and also climate smart crop production. You will excuse us today because probably it may not be very clear as such, and it's very embarrassing indeed, but that is how it is. It is not really okay, but we need to examine the major climatic risks affecting crop production. And I think we discussed this yesterday, okay? We discussed some of the adverse challenges that affect crop production. One is the scarcity of water. The other one is poor soil health, and also the land terrain. There are so many other things that affect. Climate change is real, okay? And we can have extreme temperatures, and we can have extreme rainfall that is destructive. So those are issues to do with climate change. It's outside the margin, but I believe you could. It should be somewhere there. Okay. But the idea is to identify the key climatic risks such as drought, erratic rainfall. These are things that we covered yesterday. Erratic rainfall is scarce in semi-arid conditions and arid conditions. Okay. And if that happens, we need to know and to be wise what type of crops are supposed to be grown in semi-arid conditions. Crops that require low rainfall, or crops that require minimal rain. And we gave examples yesterday like, and this is something that we can discuss. It is open to discussion. Okay. Things to do with Mbazi. You have heard of Mbazi? Yeah, they grow very well in drought areas or areas with low rainfall. We also have sweet potatoes, varieties that can grow very well in lowlands where the rainfall is actually very, very low. We talked about maize varieties, the Katumani, the 5 series, the 6 series for the highlands, and all that. It's also good to analyze these climatic extremes. And when we talk about climatic extremes, we are talking about high temperatures, ash conditions. And we have talked about how to mitigate ash conditions. We need to mitigate by getting the right varieties of crops that can actually do very well in northeastern. If we ask this just a thing out of the box, what are some of the crops that you can grow in northeastern province? What kind of crops and what kind of animals as well that you can keep in northeastern province? You know, northeastern province is very harsh. Okay, those of us who have stayed there know that it is not a walk in the park. Sometimes you may think that you are not in Kenya. Okay, so what type of animals do you keep? Can you keep in northeastern province? Yes, a camel. Yes, camels can withstand very harsh conditions. Okay, and you can milk them. Have you taken camel milk in your lifetime? Have you eaten beef from camel? It tastes like rubber. Okay? When you are eating it, it pushes your jaws like rubber. It's just, that is camels, but that's okay. Now, we propose sustainable adaptation and mitigation strategies that enhance crop production, long-term food security, and so forth. We talked about dams, harvesting water for minimal irrigation, and backyard kitchens in ash conditions and drought areas. We are not saying that climate change cannot affect islands. It does. Okay. When there is a lot of rain, what do you think will happen? Either if you are living in the slopes actually will have what we call soil grip, if you understand what is soil grip, and then eventually it will actually be flown, it will flow downstream. You remember the Marakwet issue? Have you read of Marakwet issue? Where people lost their lives because they were living on the slopes. It's a fertile area, but because of climate change issues, that's like what is going to happen. Next. Now, climate change a global challenge for agriculture. So, climate warming, scientifically recognized phenomenon. We have human-induced greenhouse gases, and this is not actually something that we may need to belabor. Today it's a little bit of chemistry, okay, not agriculture. So what are some of the types of greenhouse gases that we can be able to say? Because now you are chemists. Yeah, CO2, carbon dioxide. Yeah, what else? Yeah, we have methane. Methane is a greenhouse gas. Yeah. What else? We have CO2. We also have water as greenhouse gases, water vapor, okay, nitric oxides and so forth, or nitrous, NOx. Those are some of the examples of greenhouse gases that can affect and cause climate change. They form a blanket in the atmosphere, and then they release heat, okay, and it becomes very hot. The others is extreme weather patterns such as heat waves, droughts, floods, and erratic rainfall. I don't know what you can say about the climate in Egerton in Mau, or Egerton in general. What can you say about the climate around Egerton? Is it friendly? Very cold? Okay. Yeah, like today the temperatures were 11 degrees Celsius, which is actually very, very cold. Okay, so extreme. And you know, we used to not to have such extreme weather conditions. It's because of pollution in the atmosphere, the issues of climate change, and all that. So that is actually changing the reality. It's changing the tune. Now we have These changes directly affect agriculture production. Of course, when these things are extreme, under very cold conditions, plants don't grow as fast as you wish. They will take forever. Okay. Even maize, we're supposed to take 6 months. We take up to 8 months. And that will actually lead to food scarcity. You start buying and you don't even get them in the market. Okay. So, next. Now, why? I don't know. What is climate smart crop production? Okay. It is an approach that integrates adaptation. Okay. The most important thing here is adaptation. It has to adapt to a given environment. Every plant that you choose or every crop that you choose must adapt to a given environment. Say for example pyrethrum. If you are talking about pyrethrum, it has to adapt in the highlands, very cold regions. You cannot grow pyrethrum in Kajiado. You cannot grow pyrethrum in Kitui. Okay, so there must be that adaptability. The crop that you choose. Cassava can do very well in Makueni. Okay, depending on the variety. Some maize also can do very well in Makueni, depending on the variety. Okay, and some maize can do very well in Nyandarua, depending on variety. Siagi, potatoes, they must adapt to a given climate conditions. And I think I'm told that potatoes do very well in Nyandarua. Okay, I think that is where they do very well. Waru and a little bit of Mau here, they do also very well. But we have a variety of potatoes. Okay, it's not only one. I think there are many. There is Siangi and there is what? There is Siangi and Tigoni. Yes, Tigoni. What else? Abigail. You know, you come from where Siangi is. I don't know, but I just predict. Eh? Yeah, what? Stephen. Stephen potato. Okay, maroon. Okay, and the white ones are the Siagi.
No, the Tigoni, but the other one that they are not exactly white. Those are Siagi.
Oh, okay. But which one is more productive over the other?
Tigoni is more productive,
but
the Siagi itself has good quality compared to the other. So
which ones are being sold to KFC?
The Siagi.
Siagi, and that is where we have it in Moranga. Okay. Yeah, but there was pollution effects due to overuse of pesticides, herbicides, and all that. Okay, so that's that. And then we need to play this video. We need to play this video. Today we are not moving very fast. Okay. Yesterday we were moving very fast because we are trying to save on time, but today we are moving slowly, and we are going to give the students exercises where you can be able to do some few things here and there. Okay. Yeah, it is part of the fact that you are going to be participatory approach. We need to look at that video. I don't know whether you have technology also is something else. Okay. See, sometimes you are presenting and you are very happy and you are really very confident, and all of a sudden you try to click on a video, it embarrasses you. Okay? You get really embarrassed. Yet you are up there and then you are excited. It cannot copy. That is the embarrassment that we are talking about. Yeah. You cannot copy, is it? Next page. Now, global greenhouse gases emissions. We know what greenhouse gases are. We have given examples there. We have CO2 as a result of the source of CO2 is mainly fossil fuels. Okay, if you burn kerosene, you burn diesel and all that, in every machines, you release CO2. And then we have methane, which is also very critical. Okay, it is an organic gas. Then you have nitric oxides. These are some of the oxides that pollute the environment, and because of pollution in the environment, then they cause problems in terms of humidity, because they act as a blanket. When they go up there, they act as a blanket, and then causing now problems to do with heat changes and leading to climate impacts, which are actually very severe in some cases. We have fluorinated maybe gases that can actually deplete the ozone layer, so that it lets in the UV through the atmosphere, and then we have problems in experiencing UV effects, and it can also cause they cause burns, is it? Yeah, if we destroy the atmosphere or the ozone, then this will penetrate and cause a little bit of burns. That is, the UV radiation can infiltrate into the earth, causing burns and causing even chromosomal mutations and so forth. So that in the process, because that is part of climate change, if it causes chromosomal mutations, then you will end up having problems, because you will end up having kids that are either too short to move around. They will have beards when they are very brief. Okay. They can even continue suckling until they have beards. You wonder what is happening because of climate change. Okay. Yeah, people become brown unnecessarily because of climate change. You lose melanin. Okay. Those people who come from Turkana, they are a little bit dark because of high level of melanin. But those who come from a place like Kerukoya, Kutus, okay, they are brownish. Okay. Those who come from Western, they are also black, and so they have eaten a lot of ingege in Isum. They become black. Okay, as a result of climate change. So climate change affects everybody. It affects everybody actually, generally. So we move on to the next one. Now, these are the percentages that you can actually see. Fluorine, as you can see, is about 2% being produced from the world, actually all over the world. This is all the data. It's not very recent. And then we have methane, it's about 16%. We have CO2, which is actually about, 65% and so forth. So what causes actually climate change mainly is actually the release of CO2 into the atmosphere. The others cause it, yes, but CO2 is actually the dominant. It's the predominant gas that is actually emitted because of fossil fuels. If you burn fossil fuels, that's exactly what is going to happen. Okay, so we need to regulate the release of CO2, and the way to regulate CO2 is to plant more trees. You need to plant more trees in order for it to be able to. The trees act as a sink where CO2 can actually be absorbed by plants. Okay, and wherever you are, or as we have said yesterday, that you have to be our ambassadors. You need to go home when you buy your piece of land, start planting trees. We need to improve the tree cover. We remember in the 1980s, there is the Green Belt movement, which was crossing the Sahara region. I don't know whether you remember this. You still remember the Green Belt movement crossing the Sahara region. Okay. The Sahara region is actually very, very dry. But when you continue planting trees, the trees will actually, we can bring us rain. Is it the trees or the clouds? Yeah. So when you have so many trees, there is a lot of transpiration. Okay. And because of that transpiration, they go to the atmosphere and they form mist. They form what they call moisture, and then they form clouds, and then it comes back in terms of rain. Okay. Circulation. I think we go to next. core pillars and objectives of climate smart crop production. There are three main pillars. We have sustainable productivity, okay, achieve food security, maintaining ecosystem balance, okay. So the most important thing here is actually productivity, okay. We must produce for us to be able to have enough food security. If you don't produce, then we are actually planning to exit as early as it can be. So we have to have sustainable food production. So that is one of the pillars of crop smart production. The other pillar is enhanced resilience. Here, strengthen farm systems against these shocks like drought or flooding. Okay. So we have to make sure that we have very good farms, healthy soils, enough rainfall, enough water. Even places where we do not have enough rainfall, we involve water harvesting procedures that are likely to be sustainable. And we say that you can have water harvesting from buildings, for example, or water harvesting by putting a dam across a river so that you can harvest the water. In extreme cases, you develop a sand dam and water ponds, okay, water ponds, so that you harvest all the water during the rainy season. And after that, when you have in water ponds or dams, you start pumping the water for irrigation. And you say the irrigation methods are very efficient, especially the drip irrigation in places where water is scarce. Greenhouse mitigation. We need to be very careful. We need to adopt energy practices that do not release carbon footprint to the environment. What are these? Instead of using generators that use diesel, we use solar panels, which have actually almost zero carbon footprint. Apart from solar energy, what are other sources of renewable energy that do not release carbon footprint to the atmosphere? Biogas. Yeah, biogas is okay in small scale. Biomass, that's also very, very, very critical. Nuclear energy can be a disaster. Kenya may not be in a position to have nuclear energy in the near future. The problem with nuclear energy, it releases a lot of energy. But if it is not well handled, it can actually leak into the environment, okay, causing a lot of disasters, especially with the communities. And that's why the best place to build a nuclear power plant will be along the coastal region, so that in case of melted down, you can actually quench using the water in the ocean. Okay. But if you are not very careful, you don't have the knowledge, you do it here in Salga, it will lead into a disaster that you will never do, like the Chernobyl disaster, or the one in Japan. They used to call it Fukushima. Okay? Yeah, disaster during the tsunami time. Yeah. So apart from nuclear, well, nuclear is good, but you have to have the right technology, and you have to employ the right person with not a short wire. Okay. You need to people with the most temperament, the best temperaments. Okay. And people who are very wise. Because somebody, if you don't pay him mshahara, ataenda kulipua kitu hapo ndani, alafu useme tunaenda wote, tuenda kwa baba. Okay? So you have to be careful about that. What are the renewable energy sources? Laura? We are talking about pillar, the one that can reduce greenhouse gas emissions. Solar we are talking about, that's okay. Wind, yeah, very good. Wind energy, geothermal energy, okay. these renewable energy sources. So we go on to the next one. Now, practices must fulfill regional climates. Role of climate smart agriculture in climate adaptation. Okay, so climate smart systems provide adaptive solutions to counteract climate variability. So the climate smart agriculture will minimize climate change. Crop diversification is very important that you have crop diversification. Okay, you can plant maybe maize and also plant beans and also plant cassava, also plant potatoes, so that if the maize fails, you still have potatoes. Okay, or if the potatoes fail, you still have beans. So you don't just put your eggs in one basket. Yeah. So you have to be reasonable. Don't just plant maize. At one point, plant coffee. At one point, plant tea. You have a small piece of land for tea, one for coffee, one for animals, so that if any one of them fails, you don't fail completely. That is exactly what we call crop diversification. And then improve the soil and water management using conservation, tillage, mulching, and all that. I think this is what we discussed yesterday. Okay, unless you want us to repeat. You want us to repeat? We can repeat, yes, just for emphasis. What is mulching? Of course, we know that. We don't want to ask a small question like that. What is mulching? We know that when we plant plants, then we have to bring some either grass or biomass to cover within the plant roots. But we can also use other innovative procedures. We have wastes, such as plastics. So we can use plastics to do mulching. Of course, plastics are not very good, but that is another way of collecting waste and putting it in the farm to prevent water losses and evaporation. So precision agriculture, this is just or let's say climate resilient varieties breeding. Okay, we talked about breeds, the GMO. You know, there are GMO foods that can actually withstand any type of climate, and they have very good yields. Some of the GMO maize that we have can even yield up to how many maize crops? Up to 5. Okay, 5 for 5. Even if it is very short. It is start from Buko Chili in a talk karibu tano. That is GMO. The only problem is that they say GMO is as an issue, or if you take it, you may only get one child or something like that. You know, a lot of stories about GMO, and then the next generation may not be there. You know, that is where the problem is. The people will not rise to the occasion. That is what they are saying. Yeah. So that is a fallacy. It's not actually true. So there are biotechnology. Even here in Eastern University, we have a biotech. You know where it is? Yes, there is biotech, trying to do gene mutation, produce crop varieties, produce chicken varieties. For example, in the US, for example, a chicken takes only 7 days, and you start. It's a very big, small chicken, and then 7 days is very big, sold in the market. Beans or tomatoes, you plant a tomato in the morning, in the evening you start harvesting. Yes. That is actually the technology. That's where we are nowadays. Even in some countries, we don't need to rear goats, beef, cattle, and so forth. We go to the lab and start doing genetic mutation, biotechnology, and we can prepare beef just by using a strand of the real beef, just to take the cells and start now manufacturing. We manufacture beef in mass, Then you ask people where were the cows slaughtered. They tell you no, there is no cow to be slaughtered here. We do it in the lab. Yes, and it is very very yummy. Okay, when it is eaten, it is cooked, very yummy, very sweet. You remember we have eggs that are being generated without a chicken, is it? Yes, they come from they say from China. I don't know where they come from. China. Because of biotechnology. Yeah. Even fish, you can actually prepare fish in the lab. Yeah. And then you come and sell here in Kenya. Yes. And that is actually nothing but biotechnology. That is where the world is moving.
Plastic rice.
Yes?
Plastic rice.
Plastic rice is also another one. Yeah. You eat plastic rice. Even fruits, plastic fruits, a mango. Yeah. It's generated in the laboratory and sold to you. Or even pumpkin, or even the watermelon. Okay, yeah, you just cut it, looks like watermelon, but it's actually plastic. You know, so biotechnology, precision agriculture, where we are using AI. We said that yesterday, if you remember very well, we said that we are not going to go to the farm unless we are sure that it's actually going to rain. And how do we do that? By predicting using AI technology or Internet of Things, by collecting data all over the satellite, and then you can run the figures and crunch the figures, and you can say, okay, on Saturday there will be this type of rain, whether it's going to be heavy rain or it's going to be small rain. Is it enough for you to go to the farm and start planting? Okay, so AI prediction, precision. This is what our forefathers and our people in the village do not know. They just look at, but of course we have traditional rainmakers. I think they are there. I don't know whether, is it real?
Not real.
Are you sure they are not real? They are real, yes. Yeah, they use, I don't know, they use the knowledge of their forefathers. They can even stop rain. Yeah. Yeah, I remember even in the very olden days, people used to go and pray in the mountains, but they must be pure in heart. People should be pure, but I don't know nowadays whether people are pure. Can you go up there and start praying and in Anyesha? I was, but Kitambo, because people are very pure. Okay, they would say, no one, I should not be touched for 7 days. And I should not touch anyone for seven days. They go and pray in the mountain. By the time they are coming down, the rain is really heavy. God listens to their hearts. But nowadays, I don't know. Even if you go to see you, you know, you go to see you, by the time you are reaching the room, you are doing other things which are not see you compliant. You become uncompliant. Yeah? But okay, we are not going to bring the Bible in this. We are doing serious things. Go to the next slide. Now, here's sustainable productivity. Okay, again, climate smart crop production promotes increasing crop yields, efficiency, and sustainability. Focuses on precision farming. We have talked about that. Intercropping, agroforestry, reduce the environmental pollution, and optimizes energy use. Then we have reduce the dependency on synthetic inputs such as fertilizers, but instead we employ compost manure. Okay, so all these are critical. Okay, because if we have better production, efficiency, and so forth, the livelihood will actually increase. We increase the livelihood. We protect the environment by not using fertilizers that are very harmful, but instead we use compost manure, we use organic manure, even pesticides, like what Njema was saying. You can use rabbit urine. Okay, instead of using pesticides, we use rabbit urine and we spray, and the pesticides will actually go. Okay? So organic, we move towards organic farming, which will actually minimize climate change. Okay? There is no pollution. Pollution of any kind. So we go to the next one. I don't know why they are very small. Our eyes may not be able to read well. We don't want to employ goggles at this stage. If you employ now, what about 60? When you are 60 or 80, what will happen? So here we are building resilience in farming systems. Resilience, the ability of a system to endure. There are three terms there. What do you mean by resilience? Endurance, adaptability, and what? And recover from climatic and environmental shocks. And what are these? Just for the sake of saying, what are these shocks? Climatic shocks. Oh, okay. Climatic shocks. One of them is extreme temperatures. Okay. What about the other one? Humidity? Floods. Okay. Yeah, flooding. Extreme flooding. Okay. Some of those extreme shocks. Those are only two, but there are more. Okay. Strengthen resilience. We have said that. Soil enrichment, organic matter, and so forth. We talked about compost manure. We talked about charcoal, biochar for amendment of soil. Promote systems that are productive, adaptable, and sustainable. Crop diversification. We talked about crop diversification. Now you cannot play the video. I don't. Go to next slide. I think that's okay. There is a figure below. We don't see that figure, but it is below anyway. Yeah. So we say it. I don't know what it illustrates, but I say that the most important thing is sustainable agriculture practices (SAPs) and their integration into the integrated food system. Okay. So sustainable agriculture practices, and we know them. We have discussed this. We discussed it yesterday. We are discussing this morning. Sustainable agricultural practices that are going to be maybe to minimize gas emissions, greenhouse gas emissions, and so forth, and give us profitability. Okay, better performance and profitability. So, the figure is still saying the figure, but you don't see the figure. Climate smart agriculture, sustainable water management, and climate smart nutrient management. Okay, go next. This is what the figure is. Yeah, this is the bigger figure. This is on the other side. But there are many things that we can learn from this figure. Okay. First of all is enabling conditions. What are the enabling conditions for the farmer in order to actually produce sustainably? What are the enabling conditions? The enabling conditions are policy and finance. Policy comes from the government, okay, from the researchers. You do research, then you take it to the government, and then they give us policy. They give us boundaries on what we need to do. The other one is finance. Where do you get the finance to be able to do your farming? If you want to do a farming of undertakers, where do you get the finances? What are the source of finances? One is yourself. The other one is what? Government. Is it Nyota? Yeah? Nyota? Maybe Nyota Foundation? Yes?
You can use some Asra fund.
Asla Fund, yes. How many of us have taken Asla Fund? They have been blacklisted. Yeah, non-government organizations, SACCOs. Okay, you can get them from SACCOs. Yeah. What about merry-go-round? Repeat it to that other guy. Yes. na wamama wanaenda saa 12 wanakuja saa 3 ya usiku wanachapwa coffee because of merry-go-round. Is it sustainable? It is not. Okay. So the source of funds could be the government. Government giving subsidy to fertilizers. If the fertilizer is costing about 3,000, they can subsidize to 1,000, especially for the tea farmers, especially for the coffee farmers, and so forth. You can also take a loan from SACCOs. Okay? Yeah, take a loan from SACCO and do it, but don't misuse it. You know, you cannot take a loan and then say, I want to go to Turkana and start planting coffee to show where when mwanaume. You will not survive. You will lose everything. Okay? Because the climate there does not favor coffee. So you need to know what kind of plan you are going to have. Gender is another issue. The world nowadays is moving toward this gender equity and inclusivity. Okay. Most of the funds, if you go to a government organization or a non-governmental organization, and then you start asking them to give you funds, ladies or women will be given more compared to the men. The youth also will be given more compared to the men. And that's exactly what we're saying, that gender is now becoming an issue in farming. Ladies are venturing into farming nowadays as compared to men. Now, water resource management, this is critical. You have to manage water resource management. You have to combine what we learned yesterday and even what we have learned today. Very critical. Okay. Smart water management practices, rain harvesting, efficient irrigation, and we talked about irrigation technologies, overhead irrigation, drip irrigation, and sprinkler irrigation, and so forth. Now, when you go to the other side, we have a post-harvest innovation. Okay, you need to know, once you harvest, how do you store your produce to avoid pest invasion? How do you store them? Okay, like, okay, let's just give an example. You are a mango farmer, and you're harvesting mangoes to be sold, to be taken to the market. How will you store your mangoes? How do you store your mangoes so that you avoid rotting and all that kind of stuff? How do you store them? You are a good mango farmer, very good approach. Very good. You know, that is something. That is good. Cold rooms. Okay? You have to have cold rooms. If you don't have cold rooms, then your mangoes or fruits will start rotting. And what energy do you use for cold rooms? What is the energy? Because that's also very important for climate change. What energy? Where is the source of energy? Do you use generators? It's going to be counterproductive. Okay? Not only to the atmosphere, but also the cost involved. So what source of energy do you prefer?
Green energy, like solar.
Yes, solar energy. You have solar roofs, or what we refer to as active buildings. Solar roofs, okay, for cold storage. The ones which are being employed for flowers, okay, we have Naivasha flower farms, you have Salga flower farms, and I think there must be some here. Yeah. There are some up there. So they employ cold rooms so that it doesn't. It may feel 1 hour. Yeah, but no, talk about 1 hour because we are going to do two today. The others, we see what to do. Yeah, so we are about to be done. So umefika mwisho ama wana uko wapi? Mimi sijui uko wapi. It's like 15 kidogo, and that's like 20, something like that. Yeah, so we are done. I think we are done with that. So you can go to the next. Go to the next. Yeah, we'll go this in passing because some of these actually are repetitions. Yeah. So whenever we talk about practical resilience, of course, we know what is resilience. Ecosystem-based approaches, agroforestry, when you are planting plants and together with crops, so that when you harvest the crops, you can also harvest the tree. Either harvest the tree for timber, for fuel, for construction, and so forth. Okay. Early warning systems using forecasted data. We say that use of AI to be able to predict what time we are going to have precipitation and what time we are going to have drought. So that is something that we go next one. Yeah, we have plants, intercrop, not actually this agroforestry. Just to summarize it as agroforestry. Because in agroforestry we have the trees, and then you have the plants, and then you have the animals. The plants will like the shades and fodder. They can also act in this case for water retention and so forth for the plants and ABCD. And then the most important thing is when you have agroforestry, you harvested the tree and then you harvested the plants. Now, harvesting the tree, these are the uses, mainly for fuel, timber, maybe also for aesthetic purposes and so forth. Next. Now, we talked about this and we don't want to go back there. Let's look at greenhouse gases. Most of the greenhouse gases are methane. We have nitric oxide there. We also have water vapor and so forth. Next. Now there is a video there. I don't think we need to play, but carbon sequestration. We talked about carbon capture and then carbon storage. Okay, plants can store the soils can store carbon. Okay, we can be used by plants. First of all, we sequester. Okay. So that is something that is critical. We go on. Now, we have 8 climate smart agriculture practices. These are things that we have also discussed. We talked about yesterday. We talked about animal husbandry, okay, efficient feeding, and waste management. We need to have animals that can fit in a particular piece of land to avoid what we call overgrazing. Okay, and you collect the waste from the animal and turn back to the soils to enrich soils for better productivity. Agroforestry we have discussed just a while ago. Precision agriculture, this is optimizing water and nutrient use, and you can actually apply the technology such as AI technology. We have shuttle and speed breeding, rapid development of resilient crops, breeding of seeds, which is not actually very much different from biotechnology, but of course we know pollination. If you are developing a seed, you know, developing the seeds, we have the male and for the maize, we have the male and the female. Do you know that it exists? Yes. So what you do what you call detasseling. Wakati inaanza kutoa nini? Maua, unatoa maua ya kike. Love the ones for the male can fertilize now which one unatoa gani? Unatoa ya kike is so that it doesn't fertilize yenyewe. Okay. And then the male can fertilize the female. I don't know what you call in agriculture, but that's actually what is happening when you are developing seeds. You have the female on this row, then on the other row you have the male species. Okay. So wakati inaanza kutoa maua, unatoa maua ya kike, alafu zile za ingine inaanza kufertilize the other one. Cover crops are protecting soil, enhancing fertility and so forth. We talked about soil organic matter, soil organic carbon and so forth. Efficient irrigation schemes, we talked about efficient irrigation schemes, drip irrigation, overhead irrigation, and so forth. Next. So this is actually how to do seeding, this one, shuttle seeding, okay? We can have it fertilizing itself, or we can have the female on one row, the male on the one row, and then we remove the tassel, okay, so that it can be able to do the males can fertilize the females. Speed breeding, when you're using greenhouse, when you're using greenhouse, you can actually do speed breeding. Here we have animal husbandry, we have biotechnology, as we said, to develop a variety of seeds that are resistant to drought, that do not require a lot of water, they can mature very fast, and so forth. Then we have agroforestry there, we have AI technologies to monitor irrigation, and so forth. Can you go next? Now, challenges and future directions in climate smart crop production. Current challenges: high initial costs, limited access to climate data, and extension services. We talked about extension services. We need extension officers to go to the field to be able to help farmers practice smart agriculture. Pathways, government and NGOs investment. We talked about that. They need to provide the finances. They need to provide the policies. These are critical. Enhance research, of course, innovation in terms of biotechnology and so forth. Next. Now here, major climate risks. Of course, these are obvious. We have actually discussed this time and time again, where we say that drought, erratic rainfall, heat stress, especially during summer, floods, impact summary, of course, the summary are clear, heat stress, flooding, erratic rainfall, and the others. Go next one. I think there is a figure there, or there is no figure yet. So heat stress reduces photosynthesis, okay? Cold stress causes injury to the plant as a result of frost. And then waterlogging. What are the impacts? The impacts of waterlogging: retarded growth, and also there is change in color on the leaves of the plant because it leaches nutrients. CO2 slightly improves photosynthesis. Of course, we know that in order to photosynthesize plant food, we require CO2 for photosynthesis. Next. Yeah, so those are the impacts of what we're just talking about, whether it is heat stress, whether it is cold, and so forth. It has a lot of impact on the plants that we get. For example, in this case, if the temperature is extreme, what is going to happen? It's going to lead to reduction in the yield. Photosynthesis activity is minimized. Antioxidants activity are also minimized. Enzyme activity is minimized. Now, what about if the temperatures are very low? Leads to chilling injury, freezing injury, having frost damage to the leaves, and so forth. Now, again, here we have nitrogen. We have a lot of rainfall. We have nitrogen availability, reduced nitrogen availability because of probably waterlogging and so forth. Root absorption, reduced root absorption, nutrients, chlorophyll, and so forth. Reduced chlorophyll, and that's why you see some of the plants become yellow over time. Next. Now, crop sensitivity and growth strategies. Most vulnerable phase, reproductive stage, when the plants are about to reproduce. For example, if there is no rain during that time when they are about to reproduce, then the yield will be affected. Then we have maize, wheat, rice sensitive to drought and heat. Rice, we have tolerates waterlogging. Okay? Wheat synthesis do not. Wheat and soybeans do not. Normally, rice are grown on, they call what? Bottles, where there is a lot of water. But wheat does not do that, because they leads now to waterlogging and so forth. In fact, time of climate events determines the severity of the yields. Okay? If you time poorly when you are growing, then you may not get enough yields. Next. Now, the rain, okay, climate, soils, and so forth we talked about yesterday. Some of the presenters talked about in the slopes and also in flat lands. How do you manage the land when it is flat and so forth? Now, climate, temperatures, we have discussed that. Soil properties, the soil texture, the soil pH is very critical. You need to know what soil pH is required for a given plant or a given crop. Nutrients content define productivity. You don't need to add too much of nutrients. Just add what you are able to add. Okay. Soil water balance between irrigation and drainage. Of course, every plant, every crop requires water, but the water must be sufficient. Don't waste the water. Next. Global crop vulnerability and hotspots. High-risk crops, maize, wheat, I think coffee, high-risk regions, tropics, because of high temperatures and drought. High-risk seasons, dry season, of course, that is something which is obvious. Summer, we don't have summer here, but we have summer in Europe, we have summer in the US, we have summer in the southern hemisphere, but we don't have it here. Next. Adapting to climate risks. Okay. Adaptation. What are these? Drought resistant crops. We have looked at some of these things. Efficient irrigation, improve the soil management, hand warning. We can be able to do that using forecasting. The meteorology in Kenya, we have a good meteorology in Kenya. Where is it located? Is it located in Nairobi or in Ngong? Ngong, yes. Yeah, and nowadays they have improved. Wajana zile za kitambo za Francis Wata. Is it Francis? Francis Ngwata. I don't know whether the generation, the Gen Z, the not here, Francis Ngwata. Did you hear Francis Ngwata? Yes. Yes. That was like a manual. Nowadays things have changed. The outcomes is increased resilience and sustained food security. Next. Climate smart crop production increases productivity. We have discussed that. Resilience. It is not an option, but a necessity to ensure food security. At the end of the day, we need food security. Food for everybody. Food should be available. Food for you to be able to take in the morning, in the afternoon, and so that you can be able to have enough energy. Food security is actually at the end of it all. Next. Next is thank you. I think that is. I wanted to present more, but he said thank you. Okay. I think that's where we stop. I stop for now.